A confirmation about the audio, please. If you're able to hear me out perfectly well, the audio is clear enough. Thank you. So the portion of cyclones, is that understood? Or is there an issue which is prevalent? Any issue which is prevalent for any of you, feel absolutely free to ask that. Any issue which prevails in the portion of cyclone, because these are conceptual portions from where questions are oftentimes asked and derived from. So regardless of the distribution of questions and the question pattern in the examination, be it in prelims or in mains, you are going to find a couple of questions from these areas. So any issues which are prevalent in this, feel absolutely free to ask. Otherwise, we proceed further. Aarti, the problem is that last point, difference between the cyclone, that is tropical cyclone doesn't last for 7 days, for more than 7 days, whereas temperate cyclone lasts for a longer duration. That is because when we talk about a temperate cyclone, it is formed across the intensification of a front. So if the front in general, if you take a look at the front initially is having a shape like this. So it will take some time for the front to change its shape, eventually get distorted enough, and then eventually leading to dissipation. So this in itself takes close to around 2 to 3 weeks. Whereas when we talk about the tropical cyclone, as soon as they make a landfall, and they will make a landfall eventually under the impact of the wind motion, as soon as they make landfall, that is when they will begin to dissipate. So that is the why they don't last for more than 7 days. Okay, Nitin, why latent heat is released towards the center only? Because that is where condensation is happening. If you take a look at the entire formation of condensation, the entire condensation process, it is not as if condensation will be initiated in this area. It is not as if condensation will be initiated here or here. Condensation will always happen across the column of rising air, and that will push the existing clouds to the sides. So wherever condensation is happening, there latent heat will be released. So because the condensation is happening all across the eye, that is why the latent heat is released in the central portion. Okay? And Dinesh, why is there cyclonic formation in Bay of Bengal in December? Because heating is less in oceans because of dispersion of heat. Okay, but that also brings us to the condition where cooling is also a slower process. So while in December you have a significant amount of heating, during the month of December you have significant amount of cooling of the land. Water is comparatively warmer, but it has got more to do with the movement of ITCZ. I will talk about it also, don't worry. When they hit landmass, it causes heavy rainfall? Absolutely yes, Pranay. Okay. Now, here, as one of you had asked a question about the cyclonic circulation in the region of Bay of Bengal. So, cyclonic circulation in Arabian Sea and Bay of Bengal. Now, here understand why is it that sometimes the cyclonic circulation takes place in the case of the region of Lakshadweep and it ends up moving towards the region of Maharashtra, Gujarat. Why cyclonic circulation takes place in the region of Andaman and it ends up moving all the way across to the region of West Bengal and Odisha coastline. That has got to do with the position of the landmass. The position of the landmass, when I say, here we will consider various factors. First factor, whenever you talk about the factor of climatic interference and influence over the Indian landmass, the first thing that you should always draw is the equator. Now, this is, let's suppose, the Indian landmass. Let's suppose the peninsular region. Now, we have seen earlier that basically the ITCZ is a region of what? Is a region of low pressure. We know that whenever you hear about ITCZ, it is a region of low pressure. Ideally, ITCZ should exist at the region of equator, but they do not remain so. During the month of June and July, we will come to the portion of Indian monsoon where we will further reinforce this concept. During the month of June and July, the ITCZ moves somewhere here. This is the position of ITCZ in, let's say, June. But it is not as if somebody has picked up ITCZ from equator and kept it over the region of the northern plains. This ITCZ's movement happens very gradually. In the month of April, that is mid-April onwards, the ITCZ starts its march towards the northern part. So let's suppose this is the ITCZ in April. Now, ITCZ is a region of what? Is a region of low pressure. Now, if I take you back a few slides, here you will observe that one of the necessary conditions for the occurrence of a cyclone is a pre-existing low pressure area. If you have a pre-existing low pressure area, that can intensify into a cyclone. Now, here over the water bodies, all these regions, they have low pressure. Low pressure, right? In the month of May, the season that we are in, the time of May that we are in, this ITCZ moves further here. So all these areas, they become areas or centers of low pressure. Now, if there is immense heating, a low pressure can develop in this region. It can intensify into a cyclone, right? Now, in general, again, if let's say this is the planet, we have seen that if let's say this is the equator, these are the tropics. In between the tropics, you have the trade winds. Now, these trade winds, they are moving towards the region of the ITCZ, isn't it? These trade winds, they are moving towards the ITCZ. But what if the ITCZ in itself, that has shifted north? The ITCZ, let's suppose, has shifted somewhere here. So, the trade winds, they will be crossing the equator and then will be bending depending upon the Coriolis force. Isn't it? So that is why the trade winds from the southern hemisphere, as the ITCZ is to the north, the trade winds from the southern hemisphere, they will be crossing the equator to reach the ITCZ. And they will be bending to the right due to the Coriolis force. That is why sometimes during the month of April and May, if you have a cyclonic disturbance formed here, it is carried by the trade winds further to the north. So it is impacted by the movement of the trade winds. Now this ITCZ, it is advancing because of heating. During the winter months, the ITCZ will come slightly to the south. So that is why during the winter months, you will observe what? You will observe basically the ITCZ. All the images with regards to the movement of ITCZ, I will give it to you when we come to Indian monsoon, so don't worry about it. So during the winter months, the ITCZ, let's say during the month of October, the ITCZ is here. October. During the month of November, ITCZ will be here. During the month of December, ITCZ is here. And then in the month of January, ITCZ will indicate here. So that is why if a cyclone is created in this time, at this point of time, when the ITCZ is at its march to the south, a cyclone can develop. You will never find the cyclone to be hitting the Odisha coastline or the Bengal coastline, because this cyclone at max will go on and hit Tamil Nadu coastline and will eventually dissipate. That is why when we talk about the cyclonic seasons in India, cyclonic seasons, so those cyclonic seasons will be observed when the ITCZ is either moving to the north or is retreating to the south, because only in those conditions will the water body observe the formation of that low pressure. So that is why cyclonic seasons in India are late April, early May. Now after May, the entire ITCZ or that low pressure is over the land region, and over the land area you cannot have tropical cyclone. After that, it begins with November, sometimes late October itself, but generally November and early December. You will observe that in India, the cyclonic disturbances, they are observed only across these months. Why? Because it is at this time that low pressure is existent over water bodies due to movement of ITCZ. Okay? That is why low pressure, a pre-existing low pressure, is created in these conditions and in these areas and regions. Is that understood now? Or is there any doubt which prevails? Let me know. Is there equal chance of cyclonic formation in Bay of Bengal and Arabian Sea? No. Under general circumstances, cyclonic formation will be more frequent over the region of Bay of Bengal as compared to Arabian Sea because of host of factors, variety of factors. By tomorrow evening, we shall be able to complete a significant chunk of oceanography as well. So by tomorrow evening, you will have a complete idea, and I will then be able to summarize why Bay of Bengal naturally experiences more cyclonic formation. And Sai Babu, cyclonic seasons. See, when is it that we experience cyclones in India? So tropical cyclones in India will develop over the water bodies only. Always tropical cyclones will develop over water bodies. Now for the development of tropical cyclone, you require a pre-existing low pressure. Now that pre-existing low pressure is created when the ITCZ is a thermal low pressure. So that ITCZ, when it tends to move between the various different seasons, as and when it lies over the region of these water bodies, Arabian Sea and Bay of Bengal, that is when the conditions are conducive for the formation of cyclones. So when is it that the ITCZ lies over the Indian waters? You will observe in late April and early May. That is when the ITCZ is moving northwards, because in the month of June, as we have seen earlier, in the month, and we will take a look at it again in the portion of Indian monsoons, in the month of June, this ITCZ will be lying squarely over the northern part of India, because that becomes very, very hot, 42, 45 degrees Celsius. So ITCZ's destination is there and it tries to march north. So as it is moving, these low pressure regions will lie over the water bodies, which can create cyclones during these months. And then again during the winter, as the ITCZ is trying to retreat to the southern hemisphere, again it passes over the water bodies, creating the low pressure condition. Okay? And Sai Babu, is that understood or is there any doubt? Pranay, except frontal rainfall, all other kinds of rainfall happen in India? Yes. Frontal rainfall is not observed. And Rani, this is the session for English. So that is why, please understand, not all of us, we are well versed in Hindi. So if, let's say, I begin to explain in Hindi, many of us won't be able to understand that as well. So you have a separate session for Hindi BHLP, which is also carried out. So get a link for that. And there in the aspect, you will get an understanding about the concepts in total Hindi, in a complete Hindi language itself. So sorry to disappoint you in that regards. In monsoon season, orographic rainfall in cyclonic season. No, in monsoon season also you have cyclonic rainfall, Pranay. You have low pressure rainfall, low pressure cells which are formed over the land areas, and that is also regarded as cyclonic rainfall sometimes. Okay. Now, after this, we move ahead with the aspect of the impact of air masses on climate. The different air masses, when they end up moving in different regions, they have a varying impact on climatic conditions. So, if I ask you what kind of impacts the air masses create on climate, think about all the various different interventions that the air can bring about. For example, temperature. Let's suppose you have a warm air mass coming in an area, right? Now, that is the example of warm advection. Similarly, you have cold advection. So, warm and cold advection. What will they do? They modify the temperature. Modify the temperature of the area by providing heating and cooling. Let's suppose we have a moist air mass which has got significant amount of moisture carried by it. Let's suppose we consider a maritime air mass. Maritime means something which has originated over a water body, so that when it hits the land, it will bring rainfall. So you have maritime air mass. Air mass brings rainfall. Also, at the places where you have frontal formation, there also you have the warm air getting cooled down, and there also you have frontal rainfall. So these air masses also bring in frontal rainfall. Now, the different air masses, they will lead to creation of different types of fronts. Each of the front have their own associated weather condition. So each front will have its own associated weather condition. Like what? For example, like you have the conditions of inversion, rainfall, thunderstorm in certain cases, etc. And then different air masses can also end up creating cyclones. For example, if the front is very distinctly active, it can lead to creation of a temperate cyclone. If you have a warm maritime air mass which is interacting, that can give rise to tropical cyclones. So you have frontal cyclones, okay? Here, air masses of distinct temperature, different temperature, and also you have the creation of tropical cyclone. That is basically when you have interaction of warm and moist maritime air mass. So these are the various different influences, and there are very distinct kind of influences brought about by the air masses on the local climate of any particular area, of any particular region as well. Okay. Now, we have certain set of mains type of questions which we will discuss at the end of the session. And most of the questions are largely very simple. For example, discuss the concept of air mass and explain its role in macroclimatic changes, that is the impact of air masses on climate. Tropical cyclones are confined to an area. This we will come to an understanding after we have gained the concept of oceanography, some portion of oceanography as well. Recent cyclone on the east coast of India was Felin. This was asked way earlier. How are tropical cyclones named across the world? This naming has been repeated. Bring out the causes for the formation of heat islands in the urban habitat of the world. Would you understand by the phenomena of temperature inversion? How does it affect the weather and its inhabitants? So all these portions we shall be discussing at the end in further significant detail, that what needs to be written, how these questions need to be approached. But before that, we initiate the next topic of the day, and very important topic of the day, that is the atmospheric phenomena. Now, in these atmospheric phenomena, these are basically some of the most complicated in the sense that you have multiple interactions happening at the same period of time. So that is why, and not much of amount of information is known about the various different atmospheric phenomena that we are going to discuss here. That is why chances are that in majority of the books that you are going to study, you will be left short-handed in this case, because majority of the books, they don't deal with the various atmospheric phenomena. What is it that we are going to study here? We are going to initiate by the ENSO cycles, or rather Walker circulation. Then we will move on into ENSO cycles. That is El Nino and La Niña. Then after that, we'll move on to Indian Ocean Dipole. Then after that, we shall be moving on into Madden-Julian oscillation. Julian oscillation. Then after that, we shall be moving to the portion of jet streams. Okay. Out of these, for your prelims examination, all of these, for your prelims, what is important to be understood is, what are they? What are these phenomena? That is important to be understood for your prelims. Then here, what they are, and also where are they observed across the globe? Are they observed? Now, few of the portions are very little or not significantly understood, you can say. So mains type of question, even in the optional area, is not asked in depth from these areas. Having said that, in the mains, you can expect a question from the portion of ENSO, cycles. That also is a rare occurrence that you will find a question from ENSO cycles asked in general studies of the mains, very rare. But the portion which is important is jet streams. That is important for your mains. Okay? That is relevant and important for your mains exam. So these are the areas that we are going to cover in this particular chapter. Now for this chapter, in order to understand that, you need the basic understanding of what do we understand by pressure, high pressure, low pressure. And here we shall be using the aspect of thermal pressure. So thermal low and thermal high pressure, that needs to be understood. Okay, if you have understood that, all this portion will be easily understood. And also the tricellular model of atmospheric circulation, which we had covered last weekend. So if those portions are clear, then the entirety of this will be very easy to grasp. Okay. So having said that, let us initiate the discussion, and we will start the discussion with the very basic principle of rise and fall of air. Now, here we will look at it at a thermal perspective, or the thermal factor. Thermal factor means the influence of temperature, due to influence of temperature. Okay. Now, we have seen earlier that, let's say, a region is heated up, warmer area. So the air above it will also heat up. Now the air above it, when it heats up in this region, as the ground surface or the sea surface is heated, this air will start to rise. Okay, so on the ground surface, it will create what? Low pressure. Now this air rises up, eventually, till it cools down or till it hits the tropopause. That is when it will diverge. It will diverge. Now, eventually, it will keep on moving in the region of tropopause till it loses all its temperature, and then it will fall down. It will sink. or if it is an already cooler area or a colder region, it further brings about that sinking. So that is where on the ground surface, it will create a high pressure because of sinking air. Okay, so this will be, in general, this is observed to be a colder area. That initiates a sinking. Now on the surface, you will have movement of winds from high pressure to low pressure. These are your surface winds. Isn't it? Now, this is the same thing that we had seen earlier. In the tricellular model of circulation, we had seen one basic factor. We had basically seen that this simultaneous high pressure, low pressure creation which is happening, that induces a movement in between the latitudes. That induces a movement in between the latitudes. We had seen that, right? Now, Gilbert Walker was one of the very famed climatologists of his time. That is in the late 1800s. He was one of the celebrated climatologists. Now, Gilbert Walker observed something. He observed that the entirety of Pacific Ocean is so very wide. And he basically, just by application of his logic, he basically was convinced that, look, it is not necessary that places at the same latitude will experience the same temperature. Because even when we say places at the same latitude, you have various factors: wind pattern, closeness to the land masses, other factors also, ocean currents. So even places at similar latitude, they can experience different temperature. This was observed by Gilbert Walker. So Walker, basically when he took a look at the entirety of the Pacific Ocean, as we are well aware, that is the largest ocean across the planet. Now, across the region of equatorial Pacific, he was absolutely convinced that, look, two ends of Pacific, they will indicate difference of temperature because of differential rate of heating and cooling. And that will induce a circulation at the same latitude from the eastern part of Pacific to the western part of Pacific. And that is what was named as Walker circulation. Now, Walker was absolutely convinced that the circulation that I have just told you, that is not the only aspect of the circulation. That circulation might have an impact on Indian monsoon. That circulation might have an impact on Arabian Sea, Bay of Bengal, Indian Ocean as well. In order to investigate more about it, he thought about taking the job which will help him explore more. See, in those days, taking these kinds of jobs which would interest you more, that was very, very prevalent. Nowadays, it is a common phenomena. Whichever job you get, fair enough. Regardless of whether it interests you or does not interest you, if it is a government job, even if I have to do something that I have never dreamt of, it is a government sector job, I will take it. But Gilbert Walker was actually interested in understanding that whether the circulation that he just observed in the case of Pacific, whether it will have an impact on India or not. That is when he came to Indian Meteorological Department. It is at this point of time when our Indian Meteorological Department was always headed by some or the other British officials. And you had senior officials heading the Indian Meteorological Department. Now, in history, you would have read about the phase and the period of Lord Curzon, the Swadeshi movement, partition of Bengal. I am sure I'm making some sense to most of you that when this happened, that is in the first decade of 1900s. It was during this time when Gilbert Walker, later he was given the honor or the honorary position of knighthood. So Sir Gilbert Walker, basically, he came to Indian Meteorological Department at that point of time. And at that point of time, Gilbert Walker had one agenda. But obviously, you know, when you get into the government, before getting into the government services or before getting into the job, you have very lofty ideals that I have this strategy. And if I implement this strategy tomorrow, I'm going to become Elon Musk, etc., etc. But once you get into the role, you are stuck in that kind of a momentum. So Gilbert Walker, as long as he was in India, he could not come upon with any such discovery. Later on, his basic discovery of circulation that was utilized in order to explain El Nino, La Niña, and other conditions which exist in Pacific, and also which end up influencing Indian climate and Indian monsoon, but not during his lifetime. So here, what is Walker circulation? And why is it that Gilbert Walker basically was so interested in it? We'll come to it. But before that, another basic concept that I want you to apply your logic to, just the sheer application of logic. Because sometimes when we try too hard, even that logic escapes us. Suppose I talk about an oceanic area in the tropical or equatorial region. Let's suppose oceanic water. Now, what is the source of heat for these oceans? If I have to ask you, the most dominant source of heat, let's suppose this is the surface. What is the most dominant source of heat for the oceans? Annie, Utkarsh and Nitin, correct. Dinesh, Namita, Anand, Aarti, Shubhojit, Vivek, Anshu, good. Yara, good. So the predominant source of heating is the sun. It is the solar insolation, which is the prime source of heating. The solar insolation, which is the prime source of heating, especially in the equatorial and the tropical regions. Now, if I ask you that in a tropical or equatorial ocean, temperature will be higher where? At point 1 or at point 2 at a depth of, let's say, 50, 100 meters. Where is it that the temperature will be higher? 1 or 2? Always 1. 1 can be regarded to be the warmest region of the ocean, isn't it? So we can say that the surface is the warmest portion, warmest part of ocean in the tropical areas and equatorial areas. Now, furthermore, let's suppose here you have wind movement which is observed. Here you have wind movement which is observed. Now, as the wind is moving across the surface, can I say that the wind will be able to drag some amount of surface water along with it? Isn't it? I can say that because the surface is the warmest region. Can I not say, furthermore, that the wind is able to carry the warmest portion of the water? Now, if the wind is moving, let's suppose, carrying all the warmer waters along with it, warmer waters are being accumulated. Now, if from the surface here, let's suppose the top water or the top layer of water has been carried by the wind, which was very warm, what will happen to this region? Will that region exhibit a kind of a depleted portion where the water has been carried by the wind, or will the subsurface water come up and rise up to this region? What do you think will happen? One thing can be that because the wind has carried the surface water, so the surface is depleted, showing a kind of a depression. The second reason can be that subsurface water will emerge, it will fill that gap, in order to fulfill the vacancy. Subsurface water will rise up. Most of you agree with that? Now, this subsurface water was cooler as compared to the surface. So, can we think about it in the terms that when you have warm surface water which is carried away, the subsurface colder water comes to the surface. Now, this subsurface water, which is colder, will reduce the temperature. Now, that is observed generally across the oceans, especially across very large oceans like the Pacific Ocean. So, with these basic concepts, let us approach the portion of Walker circulation. Let us understand it with the help of the Pacific Ocean, because that is where it is generally observed. So here, let's suppose the equator. Okay. Now, around the region of equator, which are the permanent wind systems which are in existence around equator? We have seen the permanent winds. Which are the permanent winds in existence around equator? Trade winds. Very good. So when you have trade winds in existence, the direction of flow of these trade winds can be considered in this manner. The trade winds can be considered in this direction. Now, suppose I were to ask you a question. What is the general direction of motion of the trade winds around the region of equator? Leave the place of origin. Don't worry about the place where they are originating. What is the general direction of movement of the winds around the region of equator? So the general movement of winds around the region of equator, it can be thought to be summarized as, very good, beautiful, east to west, general direction of winds. It can be thought to be as from east to west. I hope we don't have any doubt in that. Now, the wind is moving to the west, the western portion of Pacific. Now, the wind is also going to carry the surface water. The surface is the warmest portion. So, all that surface water will be carried over by the wind. Now, let's suppose from this area, some surface water has been carried away from this portion. Now, as the surface water is being carried away, the subsurface water will come up. What will happen to the temperature of the surface in this region? Will it remain the same? Will it rise up? Will it fall down? What do you think will happen to the surface temperature in this area as the surface water is carried by the wind? Will the temperature remain consistent? Will it rise up? Will it fall down? Good. It is going to fall down, right? Because the surface water has been carried away. So all that warm surface water keeps on getting accumulated in the region of Western Pacific. This is where you will observe accumulation of warm surface water. Meanwhile, From the regions where the surface water has been taken away, the subsurface water is now exposed, and that will lower the temperature, isn't it? So that will lower the temperature. So in all these areas, you have colder subsurface water. Colder subsurface water come to the surface. Now, when the colder subsurface water come up, what will it do in terms of temperature conditions? This reduces the temperature, lowers the temperature. Whereas in this condition, accumulation of warm surface water, why does accumulation happen? Why doesn't the warm water be taken up till the region of Indian Ocean? Because you have obstacles in the form of land masses. So accumulation of warm surface water, all that heated water is accumulated in that area. So this will increase the temperature. The temperature significantly rises up, isn't it? So the temperature rises up in a region, temperature falls down in a region. That is something that you will observe. Now, rise of temperature is associated with the development of a low pressure. Here you have a development of low pressure. Comparatively, here you have development of a high pressure. Now, high pressure to low pressure, wind always blow from a high to a low. So here there will be a wind movement which will be observed from the region of high pressure to the region of low pressure. There will be a wind movement. This low pressure will attract winds from here also. The wind will come, it will rise up. Rise up doesn't mean it is moving towards Japan. In terms of height, it is rising up. It will rise up. As it rises up, it loses temperature, and that is when it will lead to formation of clouds in this area and will cause significant amount of rainfall in this region. The wind further rises up, diverges. Here, this portion will sink near the region of the high pressure, and you have the completion of a circulation. And that circulation which is completed, the wind movement due to the different pressures is observed at the same latitude. Unlike the tricellular model of circulation where the circulation was observed in between different latitudes, here the circulation is being observed across the same latitude. As a consequence, as a result of that, here this gives rise to a significant region which will experience very heavy rainfall and a region which will experience very dry conditions. So this region will experience very dry conditions. Very dry conditions. Now this circulation, that is what is referred to as Walker circulation. Okay, so Walker circulation, when you talk about it, the longitudinal circulation across the equatorial Pacific is known as Walker cell or Walker circulation. It happens at two ends of the region of equatorial Pacific itself. This is the kind of circulation that we are talking about, where if you observe here, the winds, that is the trade winds, they are carrying the surface water along with them. And that is where here you have accumulation of warmer water across the Australia coastline. It is measured across the Darwin coast. Tahiti is present in the central portion of the Pacific, and here you have the Peruvian coast. WX here refers to weather conditions. So here you have high pressure, means fair weather and dry condition. Here you have low pressure. Why? Because the trade winds, they will carry the accumulated warm water. That will create a low pressure. So the air or the winds will come here, rise up, form the convective clouds, bring rain, and you have an entire circulation. That is what is Walker circulation. So basically, if you talk about the Walker circulation in various different steps for your revision purposes, so trade winds blow from a general direction of east to west. These winds blowing over the vast expanse of the Pacific gain a higher speed because over a water body, you don't have enough frictional resistance. So that is why the winds are able to gain a speed. And when the winds are able to generate a speed, when they are able to gain a speed, they will be able to carry more water. So these trade winds tend to drag some amount of surface water along with them. These surface waters are warmer due to solar insolation. As these warmer waters accumulate, that creates a condition of low pressure, and this low pressure then attracts the winds, to cause convective rains across western Pacific. Is this understood? Let me know if this portion is understood or not. How those winds are so strong to travel such a large, these are planetary winds. Ideally, when we talk about these winds, the planetary winds ideally are available and prevalent throughout the planet, isn't it? So these are planetary winds, and anyways over the water bodies, the frictional resistance is very, very less. That is why all these trade winds, it is not as if one individual wind has originated and that wind has got all the responsibility that you carry the surface water. Once you reach there, ring us up and then we will send the other wind. No, these are consistent wind movements which are happening. Consistent wind movements, all these wind movements which are happening, all of them, they further push that warm water towards the western region. Okay? Is that understood? What causes the Walker circulation? The entire cause of Walker circulation is basically the trade winds. They carry, first of all, Harishwar, have you understood what is Walker circulation? Because just by knowing a terminology, please don't try to learn that terminology. Have you understood what is Walker circulation? For how many of us, we don't know, we have not understood what is Walker circulation? Kindly let me know. Have we understood Walker circulation, or is it something which is still going in the blinds? Understood? So Walker circulation is basically a kind of a longitudinal circulation, that is across the same latitude. You have a circulation happening between at the same latitude at the two ends of the Pacific. So why will that circulation come into existence? Due to creation of a colder region, due to creation of a warmer area. Why will a warmer area be created at the same latitude? And at the same latitude, you don't have a region which is so warm. So for that, again, I would like to reiterate, I hope we are clear with the fact that factors which represent the distribution of temperature, latitude is just one of the factors. So always remember, different places at the same latitude can be heated to different degrees. Why? Because you have the influence of the wind movement, you have the influence, let's say, of the movement of ocean currents, you have the movement of distribution of land and water, you have the prevailing winds. Remember the earlier module that we have talked about. So we have various different factors which bring about differential rate of heating or cooling, right? Now with that assumption, we had taken up the aspect of the equatorial Pacific. Now around the region of equatorial Pacific, different areas of the equatorial Pacific, they might get heated up at the same rate, let us assume. But here, you also have the prevalence of trade winds. These are your trade winds. Trade winds. Now, the general direction of the trade winds can be taken as east to west. They are moving from east to west. Now, as they are moving over the very vast oceanic region, these trade winds, as they are moving over very vast oceanic area, the frictional resistance will be less, isn't it? So frictional resistance or frictional force is less. When the frictional force is less, means speed is more. Speed is very high. For any agent of nature, when the speed is high, they have a greater carrying capacity. So carry surface water along with them. So they are able to carry the surface water. They are able to drag the surface water very slowly along with them. It will take months altogether, but they are able to slowly and steadily drag the surface water. In the equatorial region, the surface of the water body is going to be the warmest because that is where the solar insolation is maximum. So that is where all this dragged up surface water ends up accumulating, let's say, in this area. Now here you have the dragged up surface water which is accumulated. That is where all the warm water, accumulation of warm surface water will be observed, and that will increase the temperature, raise the temperature of that region. When the temperature is raised significantly, that will create a low pressure, thermal low pressure. That thermal low pressure will be attracting more winds. More winds are driven there. That means more surface water is being carried over. And all the meanwhile, as the surface water is being carried over, subsurface water, which is slightly cooler, that is exposed to the surface. This subsurface water is basically cooler, so it is going to reduce the temperature of the surface in this region. It will reduce the temperature of the surface here. So the temperature of the surface is reduced, meaning what? This will be colder. Here you have colder subsurface water. That means a high pressure. So movement of wind happens between high pressure and low pressure created at the same latitude. Because it is at equatorial Pacific, that is a very significant phenomena, a very prominent phenomena, because equatorial Pacific is the largest, it is the widest, and that is what is referred to as Walker circulation. Is that understood now, Vivek? Anshu, sun may not be fixed over that area only to heat. It will heat up the whole area over that latitude. Agreed. I understand, Anshu, that the whole area will be heated up. Sun, why will the sun heat up only this particular portion, and will the sun be angry at the other areas? No. Assuming that the sun uniformly heats up all the region, the wind will carry the surface water. Surface water is the warmest. So that is where the entire region or the entire movement will be, or the entire accumulated warm water will be restricted to one portion, and the other areas where that heated up portion has been removed, those other areas will experience colder water to be prevalent. Is that understood? Does it happen in equator or other latitudes also? Shubhojit, it is observed in equator. There can be Walker cycle over whole planet. So this movement has its kind of impact created across the planet as well. We'll come to it. But as of now, is this Walker circulation understood, the basics of it? Or is there any doubt which is prevalent? Okay, good. So now, when this is understood, now let us proceed to the next concept in place, and the next important concept, and that is the aspect C. This is the Walker circulation and its impact across the entirety of the planet. So here you have the accumulated low pressure over the region of Western Pacific, right? Now observe, here you have a high pressure in this region where the subsurface water was exposed. Observe, it will have an impact even in the region of Arabian Sea, even in the region of Atlantic, and so on, and Western Indian Ocean, and so on. Now, in this situation, under a normal Walker circulation, what do you observe as the conditions in Western Indian Ocean? A high pressure or a low pressure? What do you think? In these conditions, where is it that the high pressure or low pressure exists? In the region of Western Indian Ocean, in this area. Here you have a sinking air column. So here you have the development of a high pressure. In this entire region, you have a creation of low pressure. So under these conditions, under these normal Walker circulation, a tropical cyclone can be formed over the Arabian Sea, or will it be formed over the Bay of Bengal? Where do you think, out of Arabian Sea and Bay of Bengal, which will be more conducive for the formation of a tropical cyclone in this case? Clear? Very easy. It will be over the region of Bay of Bengal. Because in Arabian Sea, you already have a high pressure, sinking air. But for the formation of a tropical cyclone, you need a pre-existing low pressure to be in existence. That is why over the region of Arabian Sea, under these conditions, it is more likely to form a tropical cyclone over Bay of Bengal. Bay of Bengal. Because over Arabian Sea, you have the sinking air, creating the condition of high pressure. Now, after this, we come to the portion where the air interacts, or the wind interacts with the water body. Okay. The reason is only wind movement. Yes, Utkarsh. That creates the kind of temperature and difference, and that creates a pressure difference. Now, we come to the interaction between the air and water surface. Water here again refers to large masses of water body. Okay. From 60 degree east to 120 east on equator, why is there a wind movement from west to east? That is because a low pressure cell is created here, my dear friend. So the winds are attracted towards that low pressure. If a low pressure is created here in this region, if a low pressure is created here, winds will be attracted from this area as well. Isn't it? Remember when we were talking about the planetary winds and the permanent winds, we had talked about the fact that these exist as pressure cells rather than an entire pressure belt in existence. So that is the reason. Okay. Now, what happens when the wind moves over the water body? If the wind has got enough amount of velocity associated, the wind will be able to drag some amount of water along with it. So here, let's suppose you have a water body near a landmass. Let's suppose in this area, we have the presence of a water body. Okay? A large ocean, for suppose. It appears like a bathtub, but I hope you get the larger picture. Now here, if you observe, let's say, the wind to be moving with a significant velocity and a significant speed in this direction. Let's suppose here you have offshore winds. Offshore winds. Now the presence of offshore winds means what? That the surface water will be carried away, isn't it? Surface water will be ever so slightly carried away and dragged by these winds. Now this surface water, when it is dragged away by the winds, we do know that at the lower region, you have slightly cooler water. And as the surface is removed, what happens? Subsurface water rises up. Just like, take the case of, let's say, milk in a utensil. If you skim the surface off, there's not a depression created. The region from the subsurface that rises up to fulfill that gap. So here, as the surface water is carried away, subsurface water rises up. Subsurface water rises up. Now, that subsurface water, when it is rising up, what is the impact on temperature that it will create? The temperature, will it remain consistent? Will it rise up? Will it fall down? What is the impact on temperature created by this rising subsurface water? Let me know. Again, very good. So most of you are correct. Few of you have given the incorrect answer. So as the subsurface water rises up, it will lower the temperature of the surface. Lowers the temperature of the surface. Why? Because subsurface water is cooler. This is an upward motion of water. That upward motion of water, that is referred to as upwelling. I'll give you the definition of it as well. But here you observe an upward motion of water. Why? Because the surface has been removed. The surface water has been removed, has been taken away. So that creates a rising level of water from the lower surface. That is what is upwelling. Now, coming to the other coastline. The other coastline, the wind is moving. This wind, which had been carrying all the surface water, that is blowing. Now all that wind will be carrying the surface water, the warmer surface water. Now what will happen here? The water will start to accumulate here significantly. Warm surface water that the wind has carried, that will be accumulated here. And slowly and steadily, more accumulation means what? It will start to push down because it cannot flood the land area. It will start to push down in this region. So what will happen to the sea surface temperature here? The sea surface temperature in this region, will it remain same? Will it rise up? Will it fall down? What will happen to the sea surface temperature? What do you think? Very good. This is going to rise up. Why? Because of accumulation of warmer water. Accumulation of warmer water. So here, what have you observed? that if there is an offshore wind movement which is happening, that offshore wind movement has the capacity basically to bring about and carry the surface water along. And conversely, if there is an onshore wind movement, it eventually accumulates the water, sometimes forcing the water to go down. Isn't it? That is something we have observed. That is that upward and downward motion of water. That is what is referred to as upwelling and downwelling. So basically, if you will observe here, winds blowing across the ocean surfaces, they push the water away. Water then rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling. Upwelling can sometimes occur even across the open seas and across majority of the coastlines. Then the reverse process, that is what is referred to as downwelling. It occurs when wind causes the surface water to build up along a coastline and the surface water eventually sinks down. So that is the aspect of upwelling and downwelling in general. Okay? Any doubts in this? Or is that understood? Repeat the entire concept, Kumar, what is it? Okay. So very briefly, I will repeat it. Please try to follow, and any portion where you feel it is not understood, ask that portion itself, pinpoint that portion, rather than the entire concept being repeated. So if let's say you have, if let's assume, let's initiate the entire thing again. So what do we have here? We have a coastline, we have the surface water, okay? This is land, this is ocean, this is also another land. Now, if the winds are moving from land to ocean, okay, now these winds are referred to as offshore winds. They are moving from land to ocean. Now, as the winds are moving across the ocean, they will have the capacity to carry some amount of surface water along with them, right? Understand this aspect. Wind is able to drag some amount of surface water that is what is why is it able to drag that? That is due to frictional resistance, or rather than resistance, we can also refer to it due to frictional drag. That as the wind, let's say this is the water, as the wind interacts with the surface, it is able to drag some amount of surface water along with it. Now that surface water is the warmest. In general, the surface water is the warmest, especially in the tropical and equatorial areas. That surface water, when it is, let's say, dragged away, what happens? Will there be a depression remained in this area? No. The subsurface colder water that will rise up to fulfill that gap. The subsurface water which was colder, that will rise up to fulfill that gap which is in existence. So here, the surface water has been dragged by the wind, means the subsurface water has now risen up, isn't it? Now this subsurface water has risen up. So that is what is referred to as upwelling of water. Why has that upwelling happened? because the surface water has been carried away, meaning the subsurface water fills up that vacancy by rising up, upwelling. Now all that surface water is carried over with the help of the movement of the winds. And eventually the surface water starts accumulating here. Now, regardless of how much the winds will blow, they will never be able to carry all the warm water over to the land area. So what will happen to all that water? That water begins to be pushed down. It begins to be forced down. So here, all that warm water begins to be pushed down eventually due to accumulation. So that is downward motion. And this is downward motion is what is referred to as downwelling. So upwelling is when the water rises up. Downwelling is when the water is forced down. Why is it that upwelling will happen? The surface water is removed, so under or subsurface water will rise up to fulfill that vacancy. Why is it that downwelling will happen? More water is accumulated in an area, means eventually it will be pushed down. It has got nowhere else to go. So that is where downwelling happens. So this is observed generally across the coastal areas, but sometimes across the regions of the open seas as well. Is that understood, Kumawat? Or is that not understood? Let me know. Okay. Now, upwelling is generally observed, wherever upwelling is observed, that is very conducive for fishing activities. So upwelling is conducive for fishing. Conducive for fishing. Why? Because wherever upwelling happens or wherever upwelling is observed in general, in those areas, deeper waters, they come to the surface. And deeper waters generally, they consist of nutrients such as iron particles and so on. So here the deeper waters, when they are rising up closer to the surface, they bring nutrients closer to the surface. And these nutrients, in basically when you have these nutrients which come up, these nutrients are utilized for the growth of phytoplanktons. The phytoplankton population, that significantly ends up booming. Phytoplanktons are basically very small algal species, algae, which forms the producer community in large areas of the oceans. So this phytoplankton population starts to grow up. And when they start to grow up, they will feed the entire food chain, and that is where it is conducive for fishing. So whenever you have upwelling, colder, nutrient-rich water come to the surface. And when you have colder, nutrient-rich waters which come to the surface or come closer to the surface, encourages the growth of phytoplanktons. Because phytoplanktons, they require nutrients. Growth of phytoplanktons. And these growth of phytoplanktons, when they are observed, fish population increases, because the fishes, they consume the zooplanktons and the krills, and eventually the entire food chain benefits. Fish population increases. So that is why regions where you experience upwelling, those are the regions which are particularly conducive for fishing activities in general. Yes, Harishwar, that is correct. Okay. So that is the aspect of upwelling and downwelling. And Sai Babu, downwelling, if you take a look at it, downwelling happens when the wind causes the surface water to build up across the coastline and eventually it pushes down because you don't have any other place for the water to move. So the water is pushed down. That is what is downwelling. Okay. Now, after this, all these basic concepts, now we come to the ENSO cycles, that is El Nino and Southern Oscillation. Now, these ENSO cycles, basically, it was discovered initially by few of the Peruvian fishermen. Now, Peruvian coastline across the region of the Eastern Pacific. Now, during the months of December, if I ask you, November, December, January, what is the season in terms of summer, winter, etc.? What is the season experienced in Peru? What do you think? If we know the position, if we know the location of it. Very good, Shubhajit. I will give you the hint. Here, during the months of November, December, January, and February, you will observe or you will experience a summer season. Now, it is significantly in the some part of southern hemisphere. Now, during the summer season, there you have the trade winds which are moving. Trade winds are offshore in that area. So, the summer season in Peruvian coastline, will it be dry season or will it have lot of rainfall? What do you think? Looking at the aspect of the wind movement, etc. Will it be dry season? Will it be rainy season? Very good. It will be a dry season because the winds are moving offshore. Onshore winds are associated with rainfall, offshore winds are associated with dry conditions. So, generally, the months of summer in Peruvian coastline, generally, they are drier, right? Very, very dry. Now, during the month of December, around the Christmas Eve, around the weeks of Christmas, few of the Peruvian fishermen, when they were going ahead to catch their quota of fish, at that point of time they observed, surprisingly, the formation of very dense cloud and occurrence of very heavy rainfall along the region of Peru. Now, this was unusual because Peruvian coastline during these months is supposed to be very dry, but you had rainfall, and that too around the time of Christmas. So generally, when anything happens across or around auspicious dates, most of us, we tend to believe that it is a gift from some almighty being, some heavenly species. They have basically gifted us with some or the other benefit. So, because it brought much needed rainfall in Peru during the dry conditions, this was welcomed. And this phenomena obviously was unusual, not observed on a yearly basis. So that is where it was named as El Nino. You will hear people talking about it as El Nina. People will talk about it as El Nino, but it is El Nino, right? Because here the N has got a kind of an appendage on top of it. So they named it as El Nino or the Christ child, the translation of it, the Christ child, because it was a gift from Christ himself. That is what they thought. Now, slowly and steadily, this became very well known that there is a phenomenon of El Nino which happens across the Peruvian coastline once every few years, which brings a lot of rainfall across Peru. The climatologists got interested. The climatologists, they started investigating. And they found out that whenever Peru receives rainfall during these months, Australia is dry. They found out whenever Peru receives so much amount of rainfall, Indonesia is dry, drier than normal. So invariably, they came across the conclusion that these events are interlinked, that Peru receives high rainfall, Australia, Indonesia is dry. They named this condition as El Nino condition. But as more and more research was going on, after a few years, they found out that sometimes the reverse is also observed. That is, Peru becomes much more drier than normal. Under normal conditions, let's suppose Peru receives X amount of rainfall. During El Nino, it receives 10x amount of rainfall. But there are also conditions when even that average rainfall is not received. Peru is much more drier. And they found out that when Peru becomes extraordinarily dry, Australia is flooded with rainfall. Indonesia is flooded with rainfall. So immediately, what was the set of observations that they had? The set of observations that they had, for any theory, you need a set of observations. So what was the set of observation? The observation was that you have a condition, condition 1. In this, Peru receives rainfall and Australia is dry, very dry. And this is not an annual condition. Average or general average that is observed normally. So what they observed normally was that in the region of Peru, observance in the sense that what they experience on an annual basis, the Peruvians on an annual basis, they will experience that the months of December are generally dry and Australia receives some amount of rains. They observed that condition 1, which was named as El Nino, that sometimes brings rainfall in Peru and makes Australia very dry. But simultaneously, after a few years, they also observed condition 2, where the Peruvian coastline is extremely dry. And the Australian coastline is flooded with rains. So, heavy rains. So, this condition 2, which was discovered significantly later on, that condition 2 is exactly the opposite of condition 1, isn't it? So that is why they named it as La Niña. That is the opposite of El Nino, or translated into the girl child in general. So they observed that sometimes during certain years, the conditions can have an El Nino condition, where Peruvian region will receive rainfall, creating floods. And sometimes it can be the other extremity, where the Peruvian coastline is very dry. So they named this as an oscillating process, where on one end you have El Nino, on the other end you have La Niña. Okay? And the oscillation keeps on happening from one to the other. It happens every few years. It keeps on oscillating. And the normal conditions, that is the general average, that is something which prevails normally, or neutral condition. So the conditions, they will oscillate between the normal the El Nino and La Niña. And that is why, because it is happening in the equatorial and immediately to the south of equator, that is why it was referred to as southern oscillation, because the conditions every few years, they oscillate between El Nino, La Nina, or otherwise the normal conditions. Hence the name El Nino Southern Oscillation. Okay? Now here, basically, the normal conditions is what we have studied already. We will take a look at what is La Nina, and then we will take a look at what is El Nino and how is it that El Nino is formed. Is it one of the reasons for Atacama Desert? No, Atacama Desert has got to do with ocean currents. And when we come to ocean currents tomorrow, we'll take a look into that. When did they start to notice it? Did it start suddenly? No. Basically, some things happen and you generally make an observation about it. So observation was made much later, right? This is something which has been happening for a very long time. But people observed as a phenomena happening during the months of November, December, January, and so on lately. Okay? So here we start with the neutral conditions, the normal conditions. Neutral or the normal conditions, basically when we talk about it, this is what is observed generally under normal conditions or across most of the years. Now, generally across most of the years around the region of Peru, what kind of circulation is observed? Walker circulation, we have seen. So that is what is the neutral condition. Neutral condition is nothing but a normal Walker circulation. This is normal Walker circulation. Now, what is this normal Walker circulation? We have just now talked about it. So, trade winds which are moving. Again, I will take you back to the earlier image. So, the earlier image that we had seen, the trade winds which are moving, they are accumulating all the surface water from the eastern part of Pacific, accumulating it in the western part of Pacific, creating a low pressure in the region of western Pacific and a high pressure or clear weather condition in the region of eastern Pacific. So here you will observe trade winds help accumulate warm waters in the western equatorial Pacific Ocean, while cold waters emerge in the eastern equatorial Pacific Ocean. Now that means you will have low pressure across the region of western Pacific. Western Pacific will have low pressure, and the region of eastern Pacific will have a condition of high pressure. Low pressure associated with rainfall. High pressure always associated with very clear sky, dry conditions, lack of rainfall. So here, these cause rainfall in the region of North Australia, while due to high pressure, there's a lack of rainfall across western coast of South America or eastern part of Pacific Ocean. So the Peruvian coastline in this region remains dry. So this is basically your neutral or normal condition, which is nothing but a normal Walker circulation. Now, furthermore, let's suppose that you have these normal conditions which are created. Now, because you have warmer waters which have accumulated here, this will attract winds. Now, stronger the low pressure, stronger will be the pressure gradient force, means stronger will be the wind motion. So we can say that greater the warm water accumulated in the region of Western Pacific, higher will be the temperature, stronger will be the wind motion, isn't it? So here when you have that low pressure which is created, let's suppose here you have the low pressure created, here you have the cooler waters, excuse me, here you have the cooler waters, you have the high pressure. Now this will induce the trade winds to be stronger in between the high pressure and the low pressure, because you have a clear-cut pressure gradient force. Now these trade winds which are blowing, now think about it and let me know. These trade winds which are blowing, will they carry more warm water on the surface, or now they won't be carrying any warm water along with them? What do you think? All these trade winds which are moving from east to west, will they be carrying more warm water along with them, or will they not be carrying any more warm water? Good. Very good. It will carry more warm water along with them, because now the winds have become stronger because there is a clear-cut pressure gradient force. So sometimes what happens is that this accumulated warm water allows the trade winds to get stronger. When the trade winds, they get stronger, they carry more warm water, they drag more warm water along with them. As a result of that, as they are carrying more warm water, here the accumulated water, that becomes much more intense. And observe, in the entire region, the subsurface water is now exposed, right? The subsurface water, here you have greater accumulation of warm water. So can we say that as compared to the earlier image or the earlier normal condition, can we say that in this condition, the low pressure has got intensified? We can say so. So as a result of that, sometimes low pressure gets intensified. Low pressure gets intensified means much stronger winds. Much stronger winds. Very strong winds, they start to blow over the region. They will carry more surface water. More accumulation of warm water will take place. All the meanwhile, the subsurface water lowers the temperature in the region, lowers the surface temperature due to upwelling which is happening. So it will lower the subsurface surface temperature, and this will induce a high pressure, a high pressure. Stronger high pressure. Now you have stronger low pressure, stronger high pressure as well. Both of these, what will they lead to? Much stronger wind motion. Much stronger wind motion over a very intense low pressure. So here, the amount of rainfall over the region of the low pressure, the amount of rainfall will be very, very high. And conversely, over this area, because it is a high pressure, a much developed high pressure, it will be very dry, almost drought-like conditions. So can we not say it is an intensified Walker circulation? That is what is referred to as La Niña. So when we talk about La Niña circulation, observe that the warmer waters will accumulate significantly, but At the same time, significant portion of the equatorial Pacific will also indicate the cooler water coming to the top. So that is why it is also referred to as the cooling phase of the Pacific. Because here, significant portion of the equatorial Pacific has now cooled down because the subsurface water has risen up. So that is the cooling phase of the Pacific. So here, La Niña conditions are the conditions where a significant low pressure develops over the region of the western equatorial Pacific Ocean, while an intensified high pressure develops over eastern equatorial Pacific Ocean. In a way, it is an intensified Walker circulation. So what it gives rise to is flood-like conditions across northern Australia and drought-like conditions in the region of South America, that is Eastern Pacific. So this is an intensified Walker circulation in general. This is also referred to as the cooling phase of the Pacific. Phase of Pacific. Why? Because here it is in this phase that significant portion of equatorial Pacific that has the surface water taken away, the subsurface cooler water comes to the surface. So that is because significant portion of subsurface water comes to the surface, lowering the temperature. Lowering the temperature. Okay? Yes, Avni, that is correct. Which means a more intensified formation of what we experience naturally. And difference between El Nino and La Nina, we have not yet talked about El Nino, Ankita, so wait for it. We'll come to El Nino, then we will talk about it. Is low pressure in Indonesian plate affect the pressure of Bay of Bengal? Yes. In the simultaneous region of Bay of Bengal also, you have the creation of a relative low pressure. So this is basically the circulation in La Nina. Observe that all that warm water is accumulating eventually will be pushed down. And because it is much more intensified than the normal Walker circulation, here you will observe upwelling significantly. So this is colder waters which have come. So you have fair weather conditions in the region of Peruvian coastline, very heavy rainfall across the Australian coastline. Okay? And this is its implication in the case of India and also across the globe. Observe, significant portion of Pacific has cooled down due to subsurface water coming up. Now here again in the region of Western Indian Ocean, you will observe the conditions of high pressure. So here again, even under the conditions of La Nina, which is the region which is more probable to exhibit the formation of a cyclone? Arabian Sea or Bay of Bengal? Let me know. In these conditions, which will be more probable to form a tropical cyclone? Very good. Bay of Bengal. Because high pressure created over the region of Western Indian Ocean inhibits the formation of cyclone in the region of Arabian Sea. So under the normal conditions also, Bay of Bengal is more conducive to form tropical cyclones. Under the La Nina conditions also, Bay of Bengal is more conducive to form tropical cyclones. Okay? Does it have the impact on Indian Ocean dipole? Indian Ocean dipole is a very different phenomena, my dear friend. And Indian Ocean dipole will not be impacted significantly by El Nino, La Nina. But the impact of Indian Ocean dipole on Indian monsoon, the impact of La Nina on Indian monsoon, they can crisscross each other. But Indian Ocean Dipole, La Nina, El Nino, generally they don't have an impact on IOD. IOD is a phenomena created due to heating of the land masses nearby. So when we come there, try to interlink, but not before that. Can we predict when El Nino and La Nina happen? Yes, we can absolutely predict that. We can absolutely predict that, and with a certain level of certainty. For example, we are able to predict that this year, in the later part of this year, El Nino conditions will be forming over the region of Pacific, and subsequently 2024 will be a massive El Nino year. So we are able to predict that. For the past 3 years, which we were experiencing La Nina conditions. Whenever you have La Nina conditions, India is blessed with more than average rainfall. Whenever you have El Nino conditions, India is blessed with deficient rainfall or drought-like conditions. So El Nino is something, we'll take a look at it after the break. So here we'll take a break, a kind of snacks break in between. We'll take it for half an hour. Okay. So after the break, we come back. But before going into the break, think about a problem statement. Let's suppose I have a bucket of water. Let's suppose I have a bucket of water which is filled to the brim. Here, I have a very large fan which is operating. Very large fan blowing air in this direction, right? So, what will happen to the water when the fan is moving? So, when the fan is moving, all that water will get accumulated at the other end. Maybe it will spill over as well. What happens when we switch off the fan? We'll talk about it when we come back from the break. What happens when we switch off the fan? What will happen to the water? So we take a break till 6:05. We come back and we continue. Okay?